This video involves a problem that includes directions for reconstitution. Let's take a moment to read it. You are to administer amoxicillin from a multiple dose container. Directions for reconstitution are: add 75 milliliters of water to yield 250 milligrams per teaspoon. The child's dose is 200 milligrams BID, which recall means twice each day. We're to administer blank milliliters per dose. In this problem, the confusing thing is which numbers to use. So what does it mean to reconstitute? When we reconstitute, we are adding liquid to make the powdered medicine usable. So the 75 milliliters of water would be added to the container, but they are not part of our dosage calculation. Instead, we want to use the 250 milligrams per teaspoon. But because the problem asks us for milliliters, we want to convert teaspoons to milliliters. So we recall that 1 teaspoon is 5 milliliters. So I'm going to make this change right in my problem. Now, in order to do the conversion, we can use whatever our preferred method is. So for some of us, our preferred method is to use desired times quantity, or desired over have times quantity. In this problem, we desire to give the child 200 milligrams. We have 250 milligrams in the quantity of 5 milliliters. So we substitute these values into our nursing formula, and then we do the math, and we find that this is equal to 4 milliliters. However, not all of us prefer the nursing formula, so some of us prefer to use a proportion. One of the key things to remember in a proportion is that because the proportion includes the equal, labels that match go in equal or the same position. So we desire to give 200 milligrams. We want to know how many milliliters. We have 250 milligrams in 5 milliliters. And so I use the cross product and multiply on my diagonals. I get 250x equals 1,000. Divide by 250. And from this, once again, get x equals 4 milliliters. Another way to solve a basic dosing problem is to use the dimensional analysis approach. In the dimensional analysis approach, it's important to have our labels cancel. Notice this does not have an equals, and that's why the labels are not in equal positions. We desire to give the patient 200 milligrams, and we want to convert that into milliliters. So we use the have amount and the quantity amount that go together. We cancel out our milligrams, and once again, we get that this patient should receive 4 milliliters per dose.